Hi everybody, my name is Ajay Singh and today we are going to talk about the third Nobel Prize in Physics was awarded in 1903 to three of these scientists. We will be taking a look at what they contributed and also would be understanding the experimental setup and the other things. But first of all, let's take a look at one of the common equation which most of us would have seen. So this is uranium 238 uh, getting decayed into thorium 234 and releasing an alpha particle, which is helium ion plus gamma rays. Okay, so this equation we would have seen, we call this as alpha decay or phenomena of radioactivity. Let's get back to the contributions from the individual scientists. So Henri Becquerel in 1896, while he was doing his experiments, he observed some spontaneous radiations or emissions from uranium salts. So actually, he was doing experiments related to photoluminescence, but during the process of these experiments, he encountered a spontaneous radiation emission. Earlier, he thought it to be X-rays, but it wasn't. Eventually, the findings revealed a new phenomena which was called as radioactivity. And in this case, the emitted radiations can pass through the opaque materials as well. And we will see the experimental setup as well in a bit. But this discovery has essentially paved the way for further studies by Mary and the Pierre Curie. We will see what they contributed specifically in a bit. But taking a look at the experimental setup, very simple setup. So the photographic plate was wrapped in a black paper, and a radioactive material was kept on top of it. In between, a metallic plate having a hole was placed. So what he observed, that because of this metallic plate and the hole, he found the shadow effects, and which confirmed that the radiation could pass through the black paper very well. Before we proceed to talk about uh, the contributions by Curie couple, let's see some interesting facts about Henri Becquerel. So he born in 1852 in Paris, and so his four of the generations have contributed a lot to physics and in general to science. His grandfather, father, son, and himself. Now we are going to take a look at the contributions by Marie Curie and her husband Pierre Curie. So they tested with many substances, kind of minerals, and specifically it was pitch blende, and they tried measuring radioactivity with their experimental setup, which I'll be showing in a bit. So they used ionization chamber and the electrometer, and essentially measured the quanta of or the amount of radioactivity for the first time. And also they got polonium and radium as two elements which have more or the stronger radioactivity than uranium. And they also concluded and deduced that the radioactivity is an atomic property, not a chemical reaction. And Marie Curie termed or coined the term as radioactivity. Before that, it was just known as kind of phenomena. So these were their contributions, and we would be taking a look at their experimental setup as well. So they had ionization chamber, which is a kind of sealed chamber having two electrodes and radioactive material, for example, the uranium salt. And the quadrant electrometer was connected to this chamber, and the needle would move based upon the current developed. So essentially, the radioactivity creates the free charges and ions into the sealed chamber, and hence the current would get generated, and that was the reason for the movement of the needle, and the quadrant electrometer would measure the amount of radioactivity. So the correlation was drawn, and hence with this setup they were able to measure the radioactivity of radium, polonium, and uranium. They also deduce the fact it's a atomic property, not a chemical reaction which is happening, right? So they contributed a lot further, and because of all this, all three of them got the Nobel Prize. Very interesting fact about this pair. So they got married in 1895, and with their partnership, they had contributed a lot to the science community, especially if we talk about the Curie. So she was the first one to get the Nobel Prize, and she got another Nobel Prize in 1911, and we will be talking about that in our one of the video. But she is the only person who got two Nobel Prizes from different subjects, one in chemistry, one in physics. And then she died from the disease, which was because of the exposure to the radioactive material. We know the gamma rays are very, very dangerous, and she has kind of sacrificed her life in the service of science, in service of mankind. So we must pay a kind of homage to her contribution, and she truly deserved, along with her husband. And also they themselves isolated radium and polonium from tons of ore of the pitch blende. That is also worth mentioning. Okay, let's see the key applications of radioactivity in modern world. It is getting extensively used in medicine for the cancer treatment using radiotherapy, where the cobalt 60 isotopes used in radiotherapy. Also, nuclear medicine employs various radioactive substances for imaging and detecting the conditions in different organs. In industry, it gets used in nuclear power generation, right, using nuclear fission of uranium. Other usage are in radiography, which helps in detection of defects in metal casings. In agriculture, radiation induces mutation plants to create the improved varieties, and also helps in controlling the insect populations and reducing the pesticides use. It is also used in food packaging to maintain the freshness. In science and research, we know that carbon dating is extensively used to find the age of fossil or other historical items. So we are reaping a lot of benefits of radioactivity in modern worlds. With this, I'll close. Thank you very much for watching.